Hello, everyone. Today we will continue with our lecture on data, and we will be talking about relational databases and this structured query language. And then we will have an exercise where you would work with your group. Are you working groups together? Okay, so we have already discussed about databases, but we will quickly remind that databases, structured databases would have rows and columns. So they would be in the form of a table where in the rows we have objects. We say objects because they can be anything, including humans, such as customers, students, or patients in a hospital, and or abstract objects such as transactions in a database, climate data, or let's say biological or medical data such as tumors or specific human genome or other things that we're studying. So they can be really anything. That's why we call them objects. And then on the columns, we have their descriptions, also called features or attributes. This is what's a structured data. And so the standard query language or structured query language would be a language that allows us to send queries to the database. So, but also allows us to operate the database in terms of we can create the database itself through this structured query language. So if we want to create a database, we have a command called create table, where we would give the customer the name of the table and then the attributes that it includes and their data types. I believe we already studied about data types, but just to remind that the data types that this command specifically requires for creating a database with SQL would be, for example, integer, number. If it's a number, it can be integer, double, or float. And or if it's not a number, it would be categorical data type. So it can be text, a string, a string or text, but also it can be other things, but like music and videos. But this particular command allows us to create text, strings, and numbers. It then allows us to update the records and to delete the records if we need to. And then we can create more tables. We create one table for customers, and we can create another one for orders, and we can link them together to see which customers placed which orders. And that's why this kind of databases are called relational databases, because we can relate them. The customer is related to the tables within the database. The customers table is related to the orders table because the customers place orders. And the way we would link those is through a special ID attribute. So the ID means identification. That is a unique attribute that defines the objects in the table. So if the table is a table of customers, the unique attribute would be, for example, customer ID or a social security number. That is, there is only one social security number per person, so that it uniquely identifies that person. And then we could use that attribute to link the customers table to the orders table. Now, once we create the database, we can start asking questions to the database. That is for the purpose of running reports. So let's say if we are running a business, we would like to know how many customers purchased specific product. We can do that by sending query to the database. So the query would look something like this. The command comes first, such as select and then we will have to say what do we want to select. Select star means select everything from the database called my database, that's a table, and then where the customer age is bigger than 21. So this particular query is going to return all objects which the attribute named customer age, its value is bigger than the number 21. So we can send this kind of queries to the database, and the results that we obtain would be in a form of report. So this is about the structured data. What about unstructured data? Has anyone heard of this? Do you guys know what that is? Anyone? Okay, does anyone know what is unstructured data? If you do, feel free to speak up.
I think it is a data type that is more flexible and like with many possibilities of forms, for example, like voices, messages, graphs, or something like that. It is unstructured, meaning that it is not formed in a column and rows structure. Yeah, I think that's it.
Okay, that's correct. So it is not in a form of rows and columns. That's right. So it can take other forms, for example, graphs, such as molecular graphs, molecular structure, or graphs of, let's say, the the World Wide Web, with all the pages that are linked together. It's a graph. So World Wide Web is a graph. Chemical components, let's say the benzene molecule of the is a chemical component, and it comes in form of a graph, some sort of biological data, but it can also be pictures, videos, and sounds, music. So, which is okay. If we need to, we can convert this kind of data to a table. If we want to have it in a table format, we could go and extract certain properties from the graphs or the chemical components, or the music, and then record them in a table. So another thing is that once we have this table or database, we could run this kind of queries directly on database, but we could connect to it from our code as well. And then let's say we have a website, we could connect to the database from our website, and if customers are placing orders online, then we can save our orders into the database through our code. We can insert and update records into the database programmatically. So if this is done through a website or through a web code, such as the Perl programming language, then it's called web data. So this kind of website would be a dynamic website because it's the pages that it's showing are unique to the specific customer. So let's say customers placing an order, the web page which is being shown is specifically for the order that this customer placed. This means no one else would get the same page, but they will get a unique page crafted or generated specifically for them. So the web pages, they can be stored locally or on a web server. The database itself can be stored on the same machine where it is the web server, or it can be stored onto a remote separate machine. So if the data is too big or too large to be stored on one machine or too large to be handled by the database management system, then if we are to send queries to this kind of database, it will take a long time for our queries to respond. We could run out of resources by searching through such a huge data. We could run out of disk space or CPU time. And in that situation, so it is called big data because it is bigger than what our normal database tools are capable of analyzing within a reasonable amount of time. So if we have data that's that big, we probably would want to have a third party hosting our data instead of keeping it on our server. So there are cloud services that would host this kind of big data, and more importantly, allow us to search through the data quickly and easily, because the way these cloud services would handle this big data is by dividing it into smaller pieces and having each piece be processed by a separate machine on that cloud cluster. Okay, so the database, we consider it to be a relational database that comes in form of a table. So the table would look like this: X1, 2, 3, 4. These are the objects. The age, the address, and the order number is the actual data within the table. We can see that the age is a number, so it is an integer in terms of data type. The address will be a string because, or text, because it contains the name of the street as well as the street number for the address. And then we have this unique ID type of column. This, in this case, is the order number that uniquely identifies particular order within the orders table. So from the structured data, it has tables. The tables themselves has fields, and we can link them together. We can query these databases or provide reports. Like we said, the database is called relational because it has relationships between the tables. And so they are linked using the ID attribute, which can be also called a key or a primary key. So for example, if we want to maintain a database of student names and their IDs and addresses, we would update the data frequently because we need to insert new student names and the information for those students. If we want to retrieve the data, based on some predicate, something that we have in mind that we're interested in. For example, how many customers that have age bigger than 21. That was one query that we have seen, but we can really ask anything from the database in terms of queries. For example, give me the names of all Massey students who live in Albany, for example. So we want to update the database with new information about students that are not previously recorded. We could save all of this data just in a text file, right? We can open a notepad file or a Word document and start typing the customer names and their descriptions, their IDs, addresses, the orders they placed, and any other information. But what would happen if we do that? So we could have the flat file system and store this flat text file there. But in order to run queries, it is faster and easier to use a database management system, which is taking care of the queries, responding to them. It is creating and deleting the tables and maintaining them within its memory space, memory and CPU time, that is the process space. So the database management system would be doing this. So it is fast and efficient. Relational databases have a well-developed structure, and they're capable of having multiple users logged into them simultaneously, so the database management system would handle the issue with let's say 2 users want to update the same records at the same time. So it will handle the issue of what's called an atomic database or atomic action, is that one person needs to finish making the changes within that record, so the record will be locked during that time. So no other users, when we say users, it means humans, but they can be code, such as PHP code, connecting to the database from a website, as well as humans and codes, automatic programs. So they can send codes asking so the codes can connect to the database asking the queries. And so it'll make sure that one record is pretty much locked until the one person or user is finished updating his records, and then it will unlock it for the next user to update it. So it is handling synchronicity in this way. There are a number of the database management systems that exist. Some of them are free. For example, MySQL is a free database. It's one of the most popular open source databases. And it is enjoyed by many people because it has fast performance and high reliability, and it is also easy to use. Now, if we want to have commercial software that's a database management system, we would need to pay for it. So this kind of databases are used by large companies, including social media companies such as Google and Facebook, cell phone and iPad electronic devices makers such as Nokia, for example. So it is used by Google and Facebook, YouTube, search engines, and many online retail stores. For example, Amazon.com or Zappos.com. The database, when it's running, it just runs as a process in the background. Doesn't really have a graphical user interface where we can click on buttons or type things in this interface or visually see anything, but we could run commands at the command prompt. So as long as our database management system is installed and running, we can connect to it by going to the command prompt, and from there issue the commands to create table, to delete table, to update the records in the table. This can be done through code as well. Let's say with web page code such as Perl or ASP.NET or JSP.NET or JavaScript, they could connect to the database programmatically. First, they need to provide username and password, so authentication is completed, and then it might check for additional permissions, and then it connects. And once connection is established, we can send queries through the standard query language to the database remotely. So what is the database management system? So imagine if we have all those files saved as text files or Word documents on our local hard drive. As data grows bigger and bigger, we would be having a hard time keeping all those text files on our hard drive. First of all, because the size and the amount of files would be very big, and that would take a long time to search through them or to obtain results from the queries. So the database management system handles this for us. So what it does, it provides storage and retrieval of the data to and from a database, and then it hides the complexity of what is going on. So the data is here, database. Then we have the database management system that stores this data for us and allows us to send queries. And finally, we have the user, which it is able to interact with and connect to the database management system. It is a client-server based system. Client is a browser, let's say a web application or a user that requests a particular website. And on the website, we can do e-commerce applications, connect to a database, access the records, or obtain reports. So through the internet, it will connect to the web server that is hosting this web page, and a specific command is being issued through the hypertext transfer protocol. For example, get the page called hello.php, and then we give the 1.1 is the version for the hypertext transfer protocol that we would be using. Once we're connected to the web server, it can decide whether it wants to treat this kind of requests as remote connections and just be able to serve the queries, or the database needs to be installed on a separate machine. And in that situation, we have three machines, or what's called three-tier applications that we need to deal with. So if the database is much bigger than our house, then it would be better to host it onto a separate house or separate machine. So the web server, once it receives requests to connect to the database, will connect to the server on another physical machine in different geographic location that is holding this database. Now, when we are done with this kind of connection, we need to release the connection because it is taking up resources, memory and CPU time on that server, and having too many connections can kill the server because it can use up all of its memory and CPU time. So we need to be mindful to release our connections once we are done talking to this server. So this is the visualization of where those database and web server are placed visually. So what is a server? A server is a machine that serves requests. It can be web server, a database server, an email server. So if it is a web server, it will host web pages, such as hello.html. But it all runs on top of an operating system. So the operating system is a platform for the server. It could have a regular operating system, such as Windows or Mac, but oftentimes it will have, if it has to deal with big data, it will have a special distributed operating system that allows like multiple machines to be connected together and act as a single machine. So that's why you have this TCP/IP here. We need to show a bigger picture of this. So the operating system sitting on the bottom, and on top of it are the different servers. It could be a web server. It could be a database server such as MySQL. And then within the file system of this server are two tables here exist. The first one is called My Codes. And the second one, HTML. So if we have some large data, we might want to keep that data onto a separate machine. This will allow us to, on the web server, to process the queries faster. So where is this other machine? What is happening here? So the database is moved to a different machine on the network. So it can be accessed through the network or through the internet as needed. So if we have some sort of a big data, this is imperative, or it is very important that it is moved on to another machine, because we don't, having both the database and the web server on the same machine can cause overhead and even kill the machine if it runs out of memory. So this is what it looks like one more time. Let's see how our tables look like. There is one table called customers. it has a unique ID for each customer, and they need to be, we could use those as a primary key to link this customer table with other tables in our database. Let's say the orders table. So here we have the name, first name, last name of the person who placed these orders. We could have another table here called orders or purchases that is linked by the customer ID to the first table, and then it tells on which day and year what purchase did they make. So we could have a table called purchase products that maps the product ID with the transaction where it was purchased. And we are showing here the purchase products table. There are 4 tables in our database, and they can be linked through the ID or primary keys. So this picture is showing the schemas of our database. What the schema means, it gives the table name, the type of attributes it contains, and the data types associated with them. For example, the name description and quantity of products. So those were part of this table. So these are the attributes for that particular table. I believe in your lecture for today or for last time, you had information on these tables and linking them together. So when we're creating the table, what kind of data types we can specify? So they can be characters, which means that they are strings or letters or text. Variable character, we don't know what would be the size of this character, so then we would use variable character. Tiny text or text will be holding a string of 64K size, that is 65,000 characters. Then it can have medium text or long text that have a lot more characters on them. This is for the characters or strings or text. The numbers, what kind of numbers do we have? We have an integer. We have small integer and medium integer, and big integer. Float is a decimal point number. Double is a decimal number that we expect to grow very fast or to be bigger than the float one. So double would allow us more space for a floating point or decimal point number. Where we have to tell the size of how big we want it to be. MySQL has something called PHPMyAdmin where it so PHP has a graphical user interface where it can allow us to create PHPMyAdmin. It can allow us to create these tables by entering some information here. Then the table, the types of data types we want to use, the attributes, and when we click this button, it automatically generates for us the create table SQL language command for creating the table and sends it to the database. So this table gets created. It is the table with all its fields the way we want it to be. So as you can see, once we just set up the desired attributes and their names and data types, it creates an actual table, insert a create table command, the SQL command for creating this table, and sends it to the database. And when the table is just created, we can start inserting records into this table. So for example, insert into the glasses RUS, the column customers, and then we have to define the customers, what they are. So ID, title, surname, first name, and then tell the values we want to insert for those. So we can insert and delete records through this interface easily as it generates the SQL commands for us. We can delete the table as well. The command for this will be drop table and then give the table name. It is important that we're taking backups of our data because we could lose it. I mean, computers can get compromised through security vulnerability that's being exploited, for example, if they were not patched with the latest operating system patches, or if they were did not have an antivirus program, they could catch a virus, or a cracker or hacker could gain elevate its privileges and gain control over the system. And then we would lose the data on that machine. So it is important that we keep daily backups of our data. So for our particular database, once again, we have 4 tables: customers, products, purchases, and purchase products. And they are linked through the IDs or the primary keys. Okay, so what we discussed so far is the concepts of a database, that in structured form, it comes in form of table that has attributes or columns or descriptions, also called fields. And then we have to specify the data types for those fields. They can be numbers or strings or text. There is a graphical user interface that would allow us for free to create those commands. It creates those commands for us automatically. So table can be created. And then we can add, update the records in the table. We can back up the database, or we can delete and drop this table. So this is what we have discussed so far. Are there any questions? Okay. So next time we will continue with the database and the structured query language. And we will look at a number of commands from that SQL language.